All right, so our basis is a set of vectors. Remember, so set of vectors. There's no reason to write anything weird here. It's not the same as like an actual subspace. So our subspace here, W, we have the word span to represent every linear combination of these three vectors. But when we write out a basis, we only want to write a set of vectors, and we need that set of vectors to be linearly independent. So we look at this, we can see without the that RREF matrix below, that V2 is just -3 times V1, right? These two vectors are dependent. And so we could use either one in our basis, but our basis, we're going to go ahead, curly Q bracket, probably going to list the first one. Most of us have sort of algorithmically decided that the way we determine our basis is by looking for those pivot columns in our REF matrix, and then knowing that those are associated with our two linearly independent vectors that we need for our basis. So if we did it that way, we end up here 2, 3, -1, -2. This is a basis. Now we also know the basis isn't unique, so if you decided to use that second vector instead, completely legit, completely okay. Weird, but fine, right? We could do that. We could also decide that like we don't really like the way that the majority of the elements in that first column vector are negative, so we could go ahead and instead use the vector 1, 2, 3, -5. Any of these would work. Only way you really get in trouble, or what I've been seeing from students in terms of this particular objective, is either they want to just bring down the columns in the matrix after it's been in reduced echelon form, so they'll write down 1, 0, 0 and 0, 1, 0, which would literally be the R2 plane within R4. But no, we don't want that, because we want all linear combinations of our first and third vector. The other is that students sort of get ahead of themselves and want to write out a whole space, so they're writing things like, you know, A times that vector, and we don't want that. A basis is just a set of vectors. The second part just asks to determine the dimension. Dimension is 2. It's the number of vectors in our basis, or the number of pivots in that reduced echelon form of the resulting matrix that we made using those column vectors. But I think the cleaner of the two is it's the number of vectors in our basis. There you go. That's all of EV6.